Hello everyone, we come from Rajima Vidyalaya School. Today we're going to present about our project, the application of ultrasonic wave for algae removal. Let's go. This is our overview. Okay, continue to the introduction. Eutrophication, or known as algae bloom, is a phenomenon that occurs from the water source that rich in nutrients like nitrogen and phosphorus, causing the algae to grow rapidly and fast on the surface of the waters. When the algae die, the decomposition process by bacteria that use the oxygen dissolved in the water will occur. This causes the water become polluted and smelly. The algae also affect the aquatic life too because they can produce toxins that act on the nervous system, livers, and other organs. In the past, we solved this problem by many methods, but most methods affect the environment using a lot of electricity and may be expensive. The new way we present is ultrasonic wave technology, which works by violent vibration to the algae cell that make them down into the waters, resulting in red sunlight and causing them to die. Therefore, the ultrasonic wave technology is an energy-saving and eco-friendly technology. This is our objective: to design and develop a prototype of ultrasonic wave generator for controlling and eliminating algae and restoring water quality in water source that affected by algae bloom within a radius of 100 meters, can be report status and can be controlled via the internet. And to enhance knowledge and develop community quality of life regarding the environment and water resource management.
In the metallurgy part, we will talk about the LGD process system using ultrasonic wave consists of 1. Ultrasonic generator, 2. Transducer, 3. Water bath, 4. Display of overall operation. The next slide is the ultrasonic wave imaging device using piezoelectric transducer. The next slide is structure of ultrasonic wave generator circuit. Structure of operation of ultrasonic algae removal and control system high frequency consists of three parts: control part, sensor as display part, energy generating and collecting part. For past life mixed together, this is our results is structure of our application. In the theory section, we're using two main physical theory. The first is the speed of sound in liquid. Because liquids have volume deformation making it cannot sustain the shear force, then the speed of sound in liquid can be determined by the following equation below. And the last one is piezoelectricity phenomenon. Consists of two types. The first type is direct phenomenon. It appears when you put the physical force in the substance that called piezoelectric material, making their figure dipole bond chains, making their central ions stick together, generating the voltage. And the second one is the reverse phenomenon that using the opposite input and giving the opposite result but same on the same method. The method is pouring effect. In the results and discussion section, this is testing of intensity of wave from the wave generators at different distance. As you can see, we do it twice, and the results is the intensity of it is inversely proportional to the different distance from the wave generator. This is the testing of effect on algae. As you can see, draw figure show characteristic of algae with and without using the ultrasonic method in the water bath up to 30 days. As the result, it can control that the wave can prevent their growth and assist to eliminate them, but this method can leave the remain of them behind.
Next, testing the effect on aquatic animals. We used tilapia fish in this experiment. The first table shows the effect on the egg hatching rate and the survival rate of juvenile fish according to the tables. The ultrasonic wave had no detectable impact, and the The second table shows the effect on growth performance and survival rate of juvenile fish after passing through the ultrasonic during the egg state for 28 days. As the table, it can be concluded that the ultrasonic wave had no effect. Next, comparing the effect of two different ultrasonic frequencies, 20 and 40 kHz, this table shows that the both ultrasonic frequencies had no significant different effect. The mortality in tilapia fish is due to natural selection. It can be concluded that the fish were not affected. Next, testing the effect on other aquatic life. These two tables shows the impact of both ultrasonic frequency on the mortality rate of other aquatic species, with exposure lasting only 30 seconds. It is clear that both ultrasonic frequency had an effect on the zooplankton, but did not affect the fish. Next, testing the electrical conductivity or EC value. From the table, it can be observed that the EC for tanks with ultrasonic waves tended to decrease over a period of 28 days. And improving of water quality, it was also found that the water quality was better and more effective for the algae control for the 40 kHz frequencies. Now let's summarize. 1. A prototype was developed and tested to eliminate fast-growing algae in a reservoir tank for 30 days. It was able to completely stop the algae growth from day 1 onward. 2. The ultrasonic wave had no effect on the fish but affect the zooplankton. And this is the problem that we will continue to find a solution for. Suggestion. This study was carried out solely on a laboratory scale. As such, no testing was conducted in natural water environments. We would like to thank for the support. These are our reference. Thank you for your attention.